So welcome to our Wednesday meeting. And in case you didn't get the email, I'm not going to be available on Friday. So if you've got any questions prior to the weekend, make sure you get to them to me Thursday so I can answer them. And then don't forget that Monday is a holiday as well. And as such, what I did was next week, instead of having Monday, Wednesday meetings, I shifted them to Tuesday, Thursday. So they should be listed on the calendar that I posted in Blackboard on the right-hand side or left-hand side menu, sorry. And so it should be in the schedule there like that. Just wanted to make you aware of it. And I sent out the first progress reports to students and parents Friday, I believe. So hopefully things are going the way you want them to go. And keep working hard. Don't forget, you should be putting in 2 to 2.5 hours every day. I know that's tough to motivate yourself to do that at this point of the year when the weather's getting nicer and you're probably a little worn down from school. I understand that, but it's important that we keep working hard right till the end of the course so that you are ready for your classes next year, and hopefully have a great summer as well. So I did the sort of first set of Reeborg fundamentals last time, and I'm just going to pick it up from there and go through a few more doing examples. It's never a bad idea to kind of flick back and forth between the my video and your Reeborg tab to sort of practice things as we go along. It really helps. As well, I need to re-encourage people to make sure you read through the material in that OpenSask textbook very carefully. It goes through how to do each of the processes in detail, and it's not good enough to just kind of scan it through. Once you need to read it and you need to practice as you're going. You're not going to be able to read 2 pages of information and just remember it and then go over to Reeborg and remember everything that you have to do. You've really got to kind of go through it carefully, one piece at a time, practicing as you go. And I think you'll make fewer mistakes and you'll have better results if you are dedicating yourself to that process. Additionally, I have posted little hint videos and whatnot along the way, but there's definitely enough information in the learning materials, the textbook, and these live sessions that you should be able to complete all of the Reeborg materials, all the Reeborg assignments by the time this unit's over. I continue to mark everything pretty much as soon as I receive it, trying to get it back to you within 24 hours. And I don't think we've had too much trouble with that so far. So hopefully you're getting things back in a timely manner and you're getting feedback that helps you improve your projects. So without further ado, are there any specific questions or are there any general questions right now that I can answer before I move into Reeborg to do some more sort of in-depth discovery on the commands? Maria, yeah?
Yeah, I'm just kind of confused in step 8. Like, I'm confused on how exactly the true and false conditions are supposed to work in there. Is that okay?
Right, and in Reeborg, right?
Yeah, I'm kind of confused about that.
Yeah, we haven't gotten to that yet in these sessions, so that's actually on my agenda for today.
Okay.
So we will definitely do those. Yeah, good question. Are there any others? If not, I'll start sharing my screen and we'll get right to it. Everybody can see that okay? Okay, great. Okay, so here we go. This is about where we left off last time. I'm not going to review any of the things I did on last session. If you were unable to attend the last session, make sure you go back and watch the recorded version. It's already been posted. And today we're going to pick up with starting about, I think, step 5, step 6, where we're starting to define functions. We're starting to use our library. We're using comments, and we're bringing things over. So if I didn't already cover comments, I don't think I did. You just put the little hashtag or the number sign, and that basically tells the Reeborg program that this is supposed to be displayed in the code, but I'm not going to execute it and try to move Reeborg or do something with Reeborg with it. So internal comments are intended for people reading your code to understand what the major functions and structures in your code do. You've got to find a balance between commenting enough and commenting too little. So I'm going to try and sort of demonstrate as I go through the processes today about the right level of commenting. You certainly don't want to be commenting every line, but you also don't want to just have one comment at the top that says Reeborg does stuff. So you got to find kind of a comfortable balance, because from this point forward, part of your mark is for each of the steps and for each of the assignments is going to be internal documentation or internal comments. And that's going to continue right into the Python. It's expected that you have some internal comments on every program, and it's built into the mark. So you put a little hashtag in there, and if you want at the very beginning, you can do something to the effect of program has Reeborg searching for items, picking up and dropping off. So that would be sort of a general comment at the top of the program. And now your comments are meant for both programmers and for people who are reading your code that might not necessarily know what it's supposed to do. Because the reality of being a programmer and working in an IT industry is that people move around quite a bit from job to job and project to project. So it's very likely that any code that you develop, excuse me, any code that you develop is going to be seen by other people and is possibly going to have to be added to or fixed, debugged by people other than yourself. So it's good process, and it's expected in the industry that you document things as you do them, so that if a new programmer comes in and looks at your code, they can quickly tell what it's supposed to do and what the major structures are and what they're supposed to accomplish, so that they can do their job. And you would expect the same thing if you moved to a different company. You would expect that if you're looking at somebody else's code and you're trying to debug it or add to it and make it better or whatnot, that you need to know what they did and why they did it. So you could expect a certain amount of knowledge from the people that are reading your code. You don't have to explain to them what loops are or what if statements are. You don't need to explain how programming works or how the code works. You just need to describe what it's supposed to do, and it needs to be relatively brief, right? You don't want to fill your program up with comments. You want to give them just enough information that they can do their jobs, and not too much as to confuse the process or make it too burdensome. So usually you'll have a little copyright statement at the top for your company or for yourself, and then a general comment about what the entire program is supposed to do. And then as you have functions that you make or large logic structures that that are reasonably complex, you'd want to have a little comment above them just to give the person reading it an idea of what it's supposed to do. So that's the comment I would put at the top of the program, something to the effect that the whole point of this program is Reeborg's going to find stuff, pick it up, drop it off, and then go to the finish line. But this program, which is step 5, specifically asks you to design a custom function. Now, don't forget, you need to go to the world info button on every step so that you are sure that you are using all of the things that you're supposed to be using for each step, and also that you are building the functions that it wants you to build. Because I mean, a lot of these programs can be solved with very simple and repetitive code, but it's not enough for you to just get Reeborg to the end of the maze. You need to get Reeborg to the end of the maze in an efficient and elegant manner, such that you use 20 lines of code instead of using 300 lines of code, and that you learn how to properly use if statements and conditional statements and looping and all the other things that we're trying to teach you in this course, that I'm trying to teach you in this course, because there's stuff later in the course you just won't be able to do unless you have a really strong understanding of those 5 basic principles: data types and variables, input and output processes, conditionals, decision making, looping, and then functions. So all of those will have come into play by the time you hit our Python unit, where the level of difficulty and expectations go up. So it is really important that you're going through the Open SAS textbook, that you are doing what you're doing right now, attending the live sessions or watching the recordings after, and that you're actually learning how to do these new processes as we go. Because, like I said, you can kind of limp through the Scratch and Reeborg stuff and get through it, but if you haven't learned what you're supposed to learn by the end of Unit 3, you're going to be in just too much trouble in Unit 4. There's not enough time to learn it all. So make sure that you're doing your 2 to 2.5 hours a day, and make sure that you're using the materials, and make sure you're asking questions if you have them. But just again, you need to do things right in Reeborg to set yourself up for success in Python. So if I look at the world info, I need to create a pick two berries function in order to complete this assignment, and I'm going to have to use these commands in that process. And basically, the goal of this one is to help you build your first custom function. So you're building the function from scratch by yourself. You're not using something, a function that's already built into Reeborg. So this is the first of many custom functions you're going to make. And the basic structure for a function is you're going to have def, which is just a Python term for I'm going to define a function or create a function. And then after that, you put what it's called. And remember, you can't have any spaces in it. So you're going to have to determine, or you're going to have to decide if you want to use camel case or if you want to use snake case. And again, in general, I prefer camel case, but Reeborg uses snake case, and that's perfectly okay. So I'll use snake case because it might be kind of what you're used to just from looking at the functions that we've done so far, such as turn underscore left. You've been using that already, and it's snake case. It's got the little underscore there. So we need to create a function, and they actually told us what to name the function. You don't have to use that name, but it has to do the same thing. I'm just going to use that name that they gave us, which was pick two berries. So pick underscore two underscore berries. Oops. Berries. There we go. And then when you're defining a function, so you've got the lowercase def space, the name of the function, because you're going to have to call it later. And by call, I mean, I'll show you what I mean later. It'll make more sense there. But when you're making the function, you have to have two brackets and you have to have a colon. And now we're going to be introduced to the term white space. White space is extremely important in Python. Not all languages utilize white space. What white space does, it's basically just blank space and where you line things up. What it does is it tells Python, or Reeborg in this case, what commands belong under what statement. So when I've got def pick two berries, you'll notice that it automatically tries to indent me underneath that. And it does that on purpose because anything that is indented and underneath that line 3 there is going to be something that's done in the function and only in the function. So that's how Python can tell what belongs, or what comments or codes or commands belong specifically to each function. So anything that I indent underneath this def line is going to be part of the function. And when I'm ready to be done the function, I just go back out to the left edge again. So it's just a way of ordering things, almost like bullet points. So in my pick two berries function, what I want Reeborg to do is we assume that he's already going to be facing the strawberries. So I'm going to, before I build the function, I like to build these one step at a time. And I know that I need to move Reeborg and then turn Reeborg so that they're facing the strawberries before I worry about how to pick them up and how to drop them off. So I'm just going to leave my function for now because I don't know what's in it yet. And I'm going to get Reeborg to the right position. So in order to do that, I need to move once, which moves them straight up. And I need to turn to the left. So I'm going to turn left. And then I'm just going to test it out and make sure that Reeborg is where I need Reeborg to be. So I'm going to move this over a little bit. I'm going to hit play. You can hit play, or you can hit the step-by-step indented block. Sorry, I have to comment this out. By the way, anytime you put that hashtag or dollar or number sign in front of the line, it's known as commenting out, which means it's still there. You can still see it, but it's not going to run it when it runs the program because, as you saw, because I didn't have anything under my function that was indented down here, it thought that there was an error, so it gave me an error right away, and I couldn't even tell if Reeborg was going to move or turn left. So I'm just going to put the little number sign in front of that for now, and then I'm going to run what I have. Okay, and so this is what it looks like. All it does is move and then turn left, and then my program is done, and it's saying, hey, you didn't complete it properly, but that's fine. So now we're at the point where we're going to start looking for strawberries and picking them up. So when we are looking at the pick two berries function, in this particular program, we don't need to have an if statement because there really isn't any decision to be made. We know that there's going to be two strawberries in each row. So we don't have to have an if statement that checks if there's two or if there's three or if there's a blank space or anything like that. We know that there's going to be strawberries and there's going to be two of them, and it's going to be the exact same process each time, just going in different directions. So now we're at a point where we can actually start building this function. So I'm just going to get rid of that hashtag. So now it's going to be live. What do I need to do in order to get these two strawberries and then come back to my current spot and then dump them off? Well, that comes down to, do you understand how to move, how to turn left, how to take, and how to put? And if you've gone through the textbook part, the OpenSASS textbook part, you should know how to take and you should know how to put by this point. So now it's just a matter of building the function line by line to do what you need it to do. Okay, so the first thing I need to do is I need to move Reeborg over so that he's on top of a strawberry. So I know I need to move. Great. Then Reeborg needs to take a strawberry, so we're going to take. Then Reeborg needs to move again to get to the next strawberry. Then Reeborg needs to take that strawberry. So that's going to take us to this strawberry, and I have it picked up. So if I run my program right now, okay, it's going to get me to this point, and I'm going to have picked up both of the strawberries. Your function does not run, okay, until you tell it to run. It's almost like a phone call. Down in your, this is what I would consider the main code, and this is what I would consider up here. I would sort of consider this all header. So when you run these Reeborg programs and you have functions, Reeborg and Python will read it, but they won't use it until you tell them to use it. So you always define your functions at the top of the page, no matter where you need them in your program. You always define them at the top of your page. So, you know, for bigger programs, you're going to have maybe 3, 4, 5 functions at the top of your page or in your library. And then you call them just like a telephone call whenever you need them. So all I've done in my code so far is I've moved Reeborg up once and I've turned him left. But now I'm in a position where I can use that function that I created. So what we do is known as calling the function. And just like a telephone call, I'm going to call the function pick 2 berries. So just like you accessed the built-in command move by typing move brackets, you access the function that you made by just typing in the function name. So it's going to be pick 2 berries. And you have to remember to spell it properly. And you also have to remember to put the 2 brackets on the end. So what my code's going to do step by step is it's going to move, turn left, then it's going to run the pick 2 berries function, which means it's going to go up here and say, they wanted me to run the pick 2 berries function, which means I'm going to move, take, move, take. So when I run this program, it's going to get me, so I'll restart it. And now when I run it step by step, he moves, he turns left, and then he says, go to the pick 2 berries function and run all that code. So Reeborg says, okay, I'm going up to the pick 2 berries function. You can see how it's highlighted. Then when I'm in the pick 2 berries functions, I need to move, I need to take, I need to move again, and I need to take again. Okay? So that function is not complete. We've just got Reeborg to the end. We were just checking to make sure it works so far. And if I go one more step, it'll say something's wrong, but something's only wrong because I haven't built all the program yet. So, but everything's working up till now. So this is a good point for me to build onto my function. All right. After I've gotten to the end, I need to turn around. How do I turn around? You can turn left twice to turn around, or we can just build another function. If we think that we're going to need to turn around a lot, let's just build a function. And what you do when you're building a function is that instead of having to type all of this code out every time you want to pick 2 berries, you only need to type it out once, and then you can call it as many times as you want. So if you ever find yourself looking at your code and you see a whole bunch of repeated code, that's an indication that it should be a function. So I'm going to create a function called turnaround. So I'm going to go turn around, and anytime I want to turn around, I know that I need to turn left twice. So instead of having to type turn left twice every time I want to turn around, now I only need to use one line. I can just say turn around. Okay? And you can use functions inside other functions. Okay? So if we go back to my main function, not my main function, but the pick 2 berries function, I move, I take, I move, I take, and then I know I'm at the end of the row, so I need to turn around. So now that I've got a function called turnaround, I can now start using it. So I'm going to turn around. Once I've turned around, now I need to move 1, 2 steps to get back to where I'm supposed to drop them off. So now I need to move twice again. Move, move. So that should get me back to here. You can always stop and test when you're going, right? So I'm just going to reload, or I'm going to test it and see what's happening. So I know all this code works, and then I know I go to the pick 2 berries, move, take, move, take. Then I'm going to turn around. So watch, see how it goes down to the turnaround function because I told it to. Then it turns left once, which only gets me halfway around, then it turns left again, and then it's going to move and move, and now I'm on top of the place where I need to get rid of the berries. So once I've gotten to the point where I'm at the dumping ground, I might as well include that in my pick 2 berries function, because I know I need to do it 3 more times. So when I'm on top of that place where you're supposed to, put the berries after you pick them up, you can just do a put twice. So I'm going to put down 1 berry, I'm going to put down a 2nd berry, and then I'm done. And then what I want to do is I want to go back to my main code, okay, and then get myself ready for the next row. So I could possibly put one more function in here, but because our rows are going both ways, I'm going to just go back to my main code. So after I've run this pick 2 berries function, it's done all of this code up here, and it's used the turnaround, and it should get me to this point here where I'm sitting on top of the berry pile, and I've dumped off all the berries. So if I go back to my main code, what do I need to do next? I need to turn left. So I'm going to turn left. Then I need to move, so I can move up 1, and then I need to turn right. Now, turn right is not built into Reeborg. You have 2 choices. You can either turn left 3 times every time you need to turn right, or you can build a function to turn right. So if I think that I need to turn right in my program more than 1 time, I should make a function for turn right. So I'm going to put def turn right. And what does turn right look like? It means that I have to turn left 3 times, because turning left 3 times is the same thing as turning right once. So every time I run the turn right function, it's going to do 3 turn lefts. But I don't have, the point is I don't have to always put 3 turn lefts in down here every time I want to turn left. I just need to put in 1 line. Okay, so functions are a way for you to make your code more efficient. Instead of having to copy and paste this chunk of code every time I want to pick 2 berries, I only need to put in that 1 command. So it may not seem like it saves a lot at the beginning, but if you have to run this process 100 times, look how much code you're saving times 100. So it ends up being very important, particularly for larger programs, that you understand how to build functions and how to use them to become more efficient. Okay, I'm just going to run my program and see where I'm up to, just because I kind of forget. So I'm going to reload it, and I'm going to step through it step by step. Okay, so step by step, I move, I turn left, then I run the pick 2 berries function, which includes a move, a take, a turnaround, there's the turnaround, a move, a put, and now once it's done the last line in the function, it goes right back down to your main code again. So now after we ran that function, it says turn left. So he's going to turn left, then he's going to move, and then he's going to turn right. And I built a function for it. So when I run this step, it goes to the turn right function, and it'll turn left 3 times. 1, 2, 3, which was the same as just turning right. Because remember, turn right wasn't built into the program like turn left is. So we actually have to build it. So now I'm in a position again where I am facing the strawberries, okay? And I know I need to harvest them. I know I need to pick 2 berries. So now that I'm facing the correct direction again, and I'm in essentially the same position I was in down here, instead of having to type all of this code out again, I just need to run pick 2 berries again. So pick 2 berries. So instead of having to type in whatever 8 lines of code or 10 lines of code, I just need to type 1 line of code, and it's going to harvest these berries. So let's see if it works. Reload. Okay, so I'm just going to run through the code quickly. He runs the function. He gets there. We've been through this already. So we'll just step up, turn right, and then you'll notice we're at the second pick 2 berries instance. So we called it once for the first row. Now we're going to call it again for this new row. And if we've done it correctly, it should collect the berries, turn around, go back, and then dump the berries. So let's see if it does that. So it's gone back up to use the exact same function again. It's picking, it's moving, it's taking, it's moving, it's turning around, it's moving, and then it's putting twice. So it did exactly what we wanted it to do, and I didn't have to copy and paste all those lines. So now that I'm done my second row, looks like I'm facing toward the left. So what I need to do is turn right. Get me facing up again, and then I've got to move again, and then I've got to turn left again to get me facing this third row of berries. All right, so let's see if it works. I'll just skip through this one quickly because we think we've done it enough times. Harvest first row, harvest second row, dump, go up to the top, turn, and I'm exactly where I want to be, facing the strawberries and knowing that I need to do the exact same steps that I did on the other two rows, which was pick two berries, pick two berries. So again, I will call the pick two berries function, and it will pick two berries. So this should get me through the third function. Boom, boom. And I am right back where I need it to be. All right, and then you can do the same thing for the fourth and then get to the finish line. So the point of this exercise that we just did is you need to know how to make functions. Okay? You need to know that you need to put functions at the top of your program because they're not necessarily run as the first thing that your program runs, but you can call them like a phone call whenever you want. Anytime I need to call pick two berries, I can run that little program. It's like a littler program inside the big program. Okay? Every time I need to run turn around, anytime I need to turn around, I can just run the turn around function. Anytime I need to turn right, I can just run the turn right function. So you can get to a point where you have a whole bunch of these functions inside your main program before your main code, which is where you're actually trying to complete the exercise. That's why the library exists. If you have commands or functions that you're going to run a lot, instead of always putting them at the top of your Python code window, you just store them in a library so you don't have to look at them, and then you can call them from the library anytime you want. So you store them, you sort of store them for long-term purposes inside the library so that you can use them for this program, and you can also use them for step 6, step 7, step 8, step 9, etc. So you don't have to constantly change and copy and paste and put 15 functions at the top of your program. You can just store them all in the library and then call them anytime you want. So what I'm going to do is I'm actually going to take these functions or these functions that I built, and I'm going to put them in the library and show you how to call things from the library. So I'm just going to copy, or cut rather, the pick two berries function, and I'm going to put it in the library. There it is. I'm going to cut the other two functions as well, and I'm going to put them in the library as well. Because I've created custom functions, I should have at least one line of comment above those functions to let anybody who's reading my code know what they do. So a decent comment for this first function, pick two berries, is going to be if Reeborg, and I just put RB, if Reeborg is facing berries, this function will move and take berries, then turn around and plant them at the end of the road. At the end. I'll just kind of shorten that a bit. If you think that that your line is too long and it goes way off the screen, you can always just put it in 2 lines. Just don't forget to put another hashtag in front of it. Okay? Because remember, any line that has a hashtag at the beginning of it is going to be available for anyone reading your code, but it's not going to be run by the computer. It doesn't think that it's actually a Python code. So there's a comment you could have for define berries. And then for your turnaround function, this would be a very short comment, just turns 180 degrees. That's it, because that's what it does, turns left twice. And then for turn right function, frankly, you probably don't even need a comment for that, but if you did, you could just say turn Reeborg to the right by turning left times 3. Turning left 3 times. So that was, you don't have to have those comments word for word like that. That's just an example of sort of the length that I would expect for internal comments. And you usually have them for custom functions that you build, so that when somebody goes to your library to look at all the possible things they can do in this program, they have an idea just by reading this top comment what everything below it is supposed to do. Okay? Now this is a very short function, turn around, but I just need to read this first line that shows me it turns Reeborg 180 degrees. And then I know everything I need to know about the function, even if I don't know what turn left does. So I've got these functions in my library where they will remain saved. So I can use them for step 6, step 7, any step in the future. I've got them saved. And then when I look at my Python code, now my main code is a lot shorter and is very focused on the individual steps that you need to do and the functions that you need to call in order to get from the beginning of the program to the end of the program successfully. So I went from something like 35 lines down to 14 lines of code, which is now super easy to read and super easy to follow. So this isn't the entire one because you still have to harvest that 4th row and you still have to get to the finish line. But that gives you plenty of information to solve step number 5 if you haven't done that already. When you put code in your library, it's basically like putting it in a different location. So like a phone call, you need to have the right phone number in order to access the person on the other end. Okay, so in order to make that call, you need to know the name of the function, and you also need to let your main program know that there is a library and it's over here. So the way that you do that, and this is step 6, in case you haven't gotten to step 6 yet, at the top of your code, underneath your sort of main header line, you're going to import certain things from your library. Okay? Now, you can import everything in your library at once, but that's not very efficient. In this particular program, I only need to use 3 functions. Now, you're just going to have to pretend that it's a little later in the course, and let's say that I have 25 functions in this library, but I'm only going to use 3 of them. You wouldn't waste energy or space by bringing everything over, at least in general you wouldn't, especially if you're working on a really, really, really big project. You just want to bring over the things that you're going to use. So the way that you do that is use an import command. So, and it usually goes at the top above the functions. So, I said I usually put my thinks up at the top. Okay, I would put my library import even above that think comment. Sure, it's not indented. So I know I need to import things from my library, and I'm going to be very specific in how I do this. So what you type is from library. So you're telling it where to go to get these things. Okay, from library, import, and import is a way of telling Reeborg, I'm going to bring these functions into my program temporarily. And now you need to tell it exactly what things you want to bring forward. If you want to bring everything over, you can just put a star, and it'll bring everything over. And that's kind of the short way to do it. But again, we want to sort of be efficient. We're going to get used to bringing over just the things we need. So what do we need to bring over? We need to bring over pick 2 berries, turn around, and turn right, which happens to be everything in there at this point. So we just need to give them the name now. So we've made the phone call to the correct number, and now we got to make sure that we're talking to the right people at that house. So how do we find out, how do we talk to the right people? We give it the function name. So I know for this particular program, I need the pick 2 berries function. And then you put a comma, and then I also need the turn around function. And then I also need the turn right function. So by importing pick 2 berries, comma, turn around, comma, turn right, it's going to bring those functions over to my main code temporarily. You're not going to see it happen. It doesn't actually bring the words over and put them at the top. It just goes over here and runs them from the library when it needs to. So from the library, that's calling the place, import, pick 2 berries, that's talking to a specific person if we continue our phone call analogy. Now here's the thing that causes some people some problems, and it's a syntax error. And syntax errors are errors that you've made in the way you've spelled something, or the punctuation you've used, or the brackets or things like that cause your program to break. They're generally very easy to find, and they're generally pretty easy to fix. But in some cases, if you've just missed something minor, like a period or a little comma or a quotation mark, they can be very frustrating searching through all your code trying to find it. So this is a common error that I want to make you aware of. When you build functions, you always have to have brackets at the end of them. When you use functions or call functions, you always have to have the brackets at the end of them. When you bring them over from the library, you can't have the brackets there, otherwise it breaks it. So if you are finding that you're getting an error and it looks like you've imported everything properly and your main code looks proper, make sure that you didn't put the brackets up here, because that's a way that you can break the program, and it can sometimes be difficult to find out or to remember that you don't need the brackets there. You need them when you're making the functions and when you're using the functions or calling the functions. So let's see if this works. If this works, then it should recognize that these functions are available in my library. It should access them whenever I tell them to, and I shouldn't get any errors. And ultimately, my little Reeborg guy should end up right where he ended up right now, and everything should work the same way that it did before. The only difference being I saved my functions in the library, and then I imported what I needed in order to fix or in order to run my program. So let's see if it works here. We'll step into it. Okay, so it says from library import. So it's not, you're not going to see anything happen here, but you're going to know that Reeborg has done this step. You've told it where to go to find all these functions for the program, and it will successfully do that. If you don't get an error message, it means it worked. So when I go to the next step, great, I didn't get an error. Okay, then I'm running my think 10 just so he runs a little quicker. Now I'm going to move. Now I'm going to turn left, and now we'll know for sure if it works or not, because now I'm saying you need to run or call the pick2berries function. And we don't see a pick2berries function up here, but we also know we did put it in our library. And if this line 3 works, it should know to go to the library, and it should know what to do when it gets to the library. So let's just keep going. So step pick2berries. Okay, it looks like it's doing what it's supposed to do. It gets back, and now it's going to go to the next line of the main code. Turn left, great. Move, turn right. Now it's going to pick 2 berries. I'll just do it quickly. Good. Go up the top, turn left, pick 2 berries. Perfect. So our function, or sorry, our program, our main code, worked exactly the same way it did before, but we were able to save our functions inside the library and then use import to call those functions. And again, the benefit is every time I see pick 2 berries here, if I had done it the inefficient way, this is what my code would look like. Okay, so if I hadn't built a function for pick2berries, this is what my main code would look like, except it wouldn't be indented. Look like. Okay, pretty gross, right? So it's 42 lines long. If I didn't have a turnaround function, okay, it would be even worse. If I didn't have a turn right function, then it would be another 3 lines for every time I needed to turn right. So we'd much rather have a program that is, I think it was 14 lines long, than a program that's 40 or 50 lines long. So if I go back, I just undo those, back to where I was, you'll notice I'm now at 18 lines. 18-line program that does what I needed to do is a lot better than a 42-line program that does what I wanted to do. And I've also got the added benefit of these functions being stored for future use, so I don't have to rebuild them again. Now, I may never use the pick2berries function again, in which case it's probably you don't need it in your library, but I'm certainly going to use turnaround and turn right again because I know that future projects are going to require me to have Reeborg turn right or to have Reeborg turn around. So the ones you have in the library are generally the ones that you're going to use again. Okay? So let's just go into the next step. I'm not going to solve this one for you because I need you to be able to do these on your own. But if I go to step 6, I can go to my Python code and I can just delete what I've got, okay, including my comments. And now I'm gonna say, what's my new goal? My new goal in world info is he needs to go pick up the paper, and then he needs to bring the paper back, I believe, to the place that he started. So he starts here, he goes to get the paper, picks it up, he comes back, and he sits down to read in the same place he started. I need to know how to use move, turn left, take, and put. I need to know how to define functions, which means make your own functions, which we just did, and you need to know how to import functions from the library, which we just did. So what this program is going to do is Reeborg is going to get the paper and return to spot. That's fine. That's in general what he's supposed to do. From my library, just from the world info, what I read here in world info, I'm not going to, there's no berries in this one. I'm not going to need 2 berries. So I'm just going to go to my line where it says import, and I'm going to say I don't need the pick two berries part anymore. But I might need turnaround, and I might need turn right. So I'm going to keep those in there. Then we can just start building our code. Let's say, what does Reeborg have to do to get from here to here? Well, Reeborg has to turn left, then move, then turn, turn right, then move, then turn left, and keep going from there. And we have turn right built into our library, so I don't need to do this again. I've already done it. I stored it in the library. So the first thing I need to do is turn right. And you see how I've already saved time? I don't have to build turn right again. I already built it once. I just need to make sure that it's brought in from the library. So I need to turn right, then I need to move twice, I believe. Then I need to turn left, which is a built-in function. Then I need to move twice again. 3 times, in fact, maybe more. And you know, like when you're going through your code, it's never a bad idea just to stop and see, okay, let's see where we're at. So I'll hit reload here, and then let's see where we're at. Turns right, moves up, turns left, moves over. Oh, I moved too far. So it was very easy for me to see when I was testing it, I moved 1 space too far. So I'm going to get rid of that last line, and if I get rid of the last move, I should be in the correct spot. So now I just need to turn to my left to face the star, which is the paper. So turn left. Then I need to move twice, I believe. Move. That gets me on top of the paper. So then I'll take the paper. Then now I need to turn around. So I don't have to build that function. I know how to turn around, because I already built it and stored it in the library. Then I'm just gonna retrace my steps. Move. Then I need to turn right. Then I need to move 3 times, I think, and that should get me back into my house. And let's just see where we're at, okay? Because I've kind of forgotten where I am at this point. So let's just see where we're at. Reeborg's gonna turn, move, go get the paper, pick it up, turn around, go back up, go into his house, and I'm right there. So now I can see, because I was right here, I need to turn left, move down 2 more times. So turn left, and then move. And then I believe I'm sitting right where I need to be sitting, so that should be programmed done. So let's see if it works. Hey, Reeborg, do your thing. Go get the paper, pick it up, turn around, come up, turn to the right, move, turn to the left. Oh, I turned to the left instead of turning to the right. See? Super easy to diagnose where that happened. So my last turn, instead of turning to the right, I was facing the wrong direction. So I need to be turning to the right instead of the left. So fix it, go back. And this is programming, right? You make mistakes, and then you test it, and you debug it, and you fix those mistakes. And then, boom, 1 or more objects are not at the correct location. So what I'm thinking here is that one thing I probably missed when I was reading world info is that instead of just being on top of the checkered flag, I probably need to put the newspaper down. So let's just see here. Needs to pick it up. Have Reeborg pick up the newspaper, walk back into the house, and put the newspaper down. I didn't read that carefully enough, so I got to the finish point, but before calling the program over, I need to put it down. So now I fix that error and give it another run, and this should be the one that works. Perfect. All green. We got our check marks. We've done what it asked us to do. We've built functions. We built them on the last program, but we've still built functions. We've imported functions, and we've used them to solve the problem, which means that you should get full marks on this, and you've also included the proper comments. So that takes you through building functions. That takes you through importing and using the library. And now the last major thing that we want to do today is we want to deal with if statements. So we're going to deal with what's known as conditional logic. And I'm just going to check which is the first step that we need if statements. I suspect it might be 8 or 9, but I'm going to double check that. If statements. Okay, it's up at 11. It's not. I guess they want us to do looping before if else. I always thought I did conditionals first, but yeah, I'll do looping first, and then I'll also talk about if else. I probably can do that today. It might take us a little longer than I wanted it to, but I'll do it quickly, and then questions, of course, you can always email me, and I can answer them one by one. All right, where's my Reeborg? Where'd my Reeborg go? Okay, so we'll deal with the repeating first. So let's just let's go to step 7. Without clicking the world info button, the goal for this one, I remember, is you have to plant. You've got enough daisies, and you can tell that just by mousing over Reeborg. You can see he's got 500 daisies. He's got lots of daisies. So you're basically starting with a bag full of daisies, and then your goal is to plant all those daisies for the 1s and 0s, and then go down to the bottom and end up. And you could do this one step at a time by literally coding from the beginning to the end. Say, I'm going to move, I'm going to turn, I'm going to plant, move, plant, move. Then I'm going to go over, then I'm going to plant, move. But you can do this step by step, and eventually you get to the end of the program, and you get the green check. But you wouldn't get full marks because you're not learning the things you need to learn. Okay, so if we look at the world info button, it'll tell you what do you need to learn in order to do this properly. In this one, you have to build a function called draw1 that'll draw the 1, and you need to create a function that will draw 0 to draw the 0s. So every time you hit a 1, if you're in the right spot, it'll draw the 1 for you automatically. All you have to do is call the function that you made called draw1. Every time you come across a 0, you're going to run the draw 0 function, and then so on and so forth until you get to the end. So this one's very similar to the last program, where we have to build a function and we have to put it in the library, and then we have to call the function and execute it. The only difference for this one is that we're going to be able to use something called a repeat so that we don't have to keep typing the same things over again. So that's the main difference between this one and the last one. Now, this is a very specific program, and there isn't going to be another step where you have to draw 1 and draw 0. This is the only step that this is going to be good for. So there really isn't a whole lot of point in putting these functions into the library. You don't really want to have functions in your library that you're never going to use again. You want to have it for things that you know you're going to use, such as turning around, turning to the right, maybe checking if there's a wall there, something like that. If we're only going to use draw 1 and draw 0 for one program only, you might as well just define it inside your regular program and not put it in the library. In fact, I'm going to go back to my library right now, and I know I'm never going to need pick 2 berries again. I used that for step 5. It's never going to come up again in the course. So you might as well just get rid of that function. We already used it. We used it successfully. We saved our program. There's no sense in clogging my library up with it because I'm never going to use it again. Now, be careful though. You need to save your projects every time you finish one. You can't just do one after the other, get your check marks. You need to hand them in to me. So I need to be able to take your program. I know I've done this before, but I just want to reiterate how you do that. After you've got your program working and you've got your check mark and everything looks good, you save your code by going up to this little guy right here, clicking on it, and then what it does is it will try to download the file. Now, some of you will have an antivirus that says, do you want to save this? Just hit keep. They're okay. There won't be any virus or anything like that, so you can keep. And then if you want to, say you only get half done, you want to come back later and fix it, then you would load the file that you saved just by going to the folder beside it, and then you find where you saved it, and I'm saving mine in downloads. Downloads is probably where it's going to go by default, so make sure you know where your downloads folder is on your computer. I'll open it up, and then all my code that I had saved will be there, and I didn't have anything in my main code window. So now I'm going to show you how you do repeats, and I know that I've already saved everything that I had from before. So just be careful that you're constantly saving it. Every time you finish a step, save it, save it, save it. Okay, so I know what I need to do for this one. I should always have a comment at the top. Okay, so I'm going to use 2 functions to plant daisies in a certain pattern. That's really what we're doing here. We're just planting daisies, and we're going to create 2 functions. Hey, I'm going to throw the fake 0 at the top here so that my program will run quickly. And I'm going to build my function right inside my main code. So I'm going to, you don't have to do this, but I'm just showing you kind of how you separate the functions with your main code. So my functions are going to go up here. And I know I need to have 2 functions. I need to have one function that's called draw1. and I need to have another function called fdraw0. Okay. And I don't have anything in there yet because I don't know what they're going to look like. But what I want to do is I want to get Reeborg to the point where he's going to use the first function. So if I'm going to plant daisies starting in column 2, going upward, I should move over 1 and I should turn to the left. So I probably am going to need turn right in this program. I might need turn around in this program. So it's not a bad idea right off the bat to, whoops, from library, import. And the two things I think I'm going to need in this one that are already in my library would be turn right. Remember, don't put the brackets in. And I'm also going to need turn around. Okay, I think I'm going to need them. You may not know at the beginning, but when you run into a situation where you need to turn left or turn around or do whatever else, then you can just put that import line in and get it. I had a question there from Maria. Why is there a think zero? Think zero is just the pause that Reeborg takes before he does a step. So for instance, let's just say I have move. Okay, so I've got those steps. If I have, it's just the time in milliseconds. If I have think 1000 milliseconds, okay, watch how the program runs. Okay, he moves, then he thinks, he moves, he thinks. So it's very slow, right? Because he's taking 1000 milliseconds, which is 1 second, each time that he executes a step. However, if I change that down to 10, now he's only thinking for 10 milliseconds, so it's going to be a lot quicker because he's not thinking for as long. So now if I run the program, he'll move almost so quickly you couldn't see it. So I put that think command in there. Just to think zero means he's not thinking at all. He's just running it line after line after line. If you don't need to go through it really slowly, you just want to see if he's going to get to the right spot, the think zero allows you to do that. Now, frankly, I don't use it anymore because built into this website is this step through button, and you can achieve essentially the same thing by going step and then just grabbing the slider and then dragging it. So you can drag them back and forth, and it's just as quick as running the program. So I don't typically use just the regular run button anymore. I usually just debug it, and then if I want to skip to a certain line, I just go, and then he's where he's supposed to be. So either way is fine. Oh, you don't need to use it either. But if you are just using the run button and you find it too slow, you can use think to make it speed up. So however you do it is fine by me. Where was I at? Oh, I have these two functions that I hadn't built yet. But I said I want to get to the point where I need to run those functions before I start building my functions. So if I reload my program, he's down in the corner here. I need him to move once and then turn left. And then after that, he'll be pointing up and facing the first daisy. So I know in my main code, I need to move. I need to turn to the left. Okay, and that gets me facing up and in front of the first daisy. Now what I'm going to do is, well, I'm at the point where I need to start moving and taking planting daisies. So I'm going to run the draw, and it's a 1. I'm at the column that's a 1. So I'm going to run draw the 1 function. Now the problem here is I haven't built the draw 1 function. It doesn't do anything yet. This is the point where I would go up and start building that function. Now I'm going to comment out draw 0 for now because it'll cause me an error if I don't when I try to test what I've got so far. So what do I think I need to do to draw 1? I'm right here facing upward, so I need to move. So that's definite. I need to move. This gets me on top of the first place where I need to plant. So planting in this case is a put. So I'm going to put. Then I need to move. Then I need to put. Then I need to move. How many are there? There's 5. Okay, put, move, put, move, put, move. Hopefully you're noticing that there's a pattern here. Okay, so I think that's what, 3 of them? Put, move. Every time that you've got repeated code, especially if you've got lots of repeated code, there's a more efficient way to do things. Okay, so I am going to run my code. I'm going to see where I am. When I run my code, it looks like he back this up a little bit so that you can see what's going on here. He's going to move, turn left, and then he's going to execute the draw one function. Okay, so there's the move, there's the turn left. Now he moves into the draw one function, which is move, put, etc. So he moved, now he's going to put, now he's going to move, now he's going to put, now he's going to move, now he's going to put, and now he's going to move. And you can see, kind of difficult to see, but you can see that he planted daisies here. Okay. So it was successful. We were able to plant our daisies, but it took me this much code to plant those daisies. So because there's repeated code there, we can use something called a loop, which is just repeating something in order to make our life easier. And what a repeat looks like in Reeborg, it looks a little different in Python, but this is how it looks in Reeborg. It's just literally the word repeat, and then how many times do you want to repeat it? Well, I'm going to want this to repeat 5 times because there's 5 daisies. So you put repeat 5, colon, and now you've got to make sure that you're indented under the repeat. So it's almost like putting like a Tupperware container inside a Tupperware container inside a Tupperware container. So for the function draw one, because repeat 5 is indented, we know that repeat 5 belongs inside the draw one function. Now also, if we go down to the next level, because these lines are indented under the repeat 5, we know that anything indented under the repeat 5 is going to be repeated 5 times. So what do we need to do 5 times? It was move and put, right? So the first thing we need to do is move, and the second thing we need to do is put. Okay, so instead of having to write 10 lines for that, I can just repeat these 2 things 10 lines. Because what did I have there before? I had the exact same thing. It's just instead of repeating it, I had move, put, move, put, move, put, move, put, move, put. Okay, so anytime you run across code that you see that repeats itself in a very consistent manner, has to be perfectly consistent, then you should be using, that should be the sign in the light bulb above your head that goes, I should be using a repeat for this. So let's see if this still works. Now I'm going to do the same stuff. I'm going to move, I'm going to turn left, and I'm going to draw one. But inside draw one, instead of having all those lines of code, it's going to do the same thing in less code, and it's more efficient. So let's restart our program, and let's run it step by step, and let's see what happens. Okay, so he moves, move, plant, move, plant, move, plant. And then he's done. Okay, now the only difference between what we had before and what we have now is that instead of moving up out the top, he stayed on this last row. So in my original code, I had him moving up here. Okay, this time he's staying on this daisy. That's not going to cause us any problems. So that's our draw one. Every time we get into a position where we're facing a column of 5 daisies, excuse me, we can just run our function in order to automate that process. So now let's get ourselves into position to draw a 0. Right? Now we could go all the way back to the bottom and start from the bottom again, or we can just move over or move up and then move over and then get ourselves to a good point. So what I'm going to do here, just to get myself into a good position, is instead of putting a move inside this repeat 5, I'm going to have it indented like this. Now this is a very important concept. Because this move is not indented, it does not belong to the repeat. So these 2 things are going to be repeated 5 times, but this move is lined up in the same place as the repeat. So it's not part of the repeat, but because it is indented once, it is part of the draw one function. So this move statement right here is only executed when you're running the draw one function, but it is not part of the repeat 5. Okay, so like I said, it's just like folder layers. It's boxes inside of boxes or Tupperware containers inside of Tupperware. Okay, so you got to be very careful about white space. And when we say white space, remember, it's just this blank space that we include before each line of code. And that's what tells it what belongs to it. So the things that belong to the draw one function are repeat 5 and move. The things that belong to the repeat 5 are just the move and put. And the only way we can tell that is by the number of spaces in front of it. Okay, so let's get ourselves in position to draw this line on the 0. And in order to do that, we're going to be right here, and we need to get over here and facing down. So we need to turn right, move twice, and then turn right again. So after draw 1, we're going to turn right, and we are going to move and then move. Now I could have done repeat 2 move, but that's not actually going to save us any code because it's 2 lines anyway, right? So move, and then turn right again, and let's run it and make sure that we are where we want to be, which is at the top of the 0 on the left side facing down. If that's where we are, then we're in good shape. So I'm just going to quickly run this program, and it looks like I am where I want to be. I'm at the top, I'm facing down, and the reason that I want to be here is because just like being down at the bottom of the first column of daisies, now I'm in a position to plant 5 daisies in a row, and I already have something built for that. Okay? Now, it specifically asks us to build a function for draw 0. And we're going to use, this is kind of neat, it's called embedding functions. And it means basically I'm going to use one function inside another function. And we already did this once. I believe when I built the pick2berries function, I had accessed the turnaround function inside that one. So you can put these inside each other too. So when I draw 0, what I want to do is first thing I want to do is I want to draw a 1, because the exact same shape, which is 5 daisies in a vertical manner, is in the 0. It's in the 0 twice. So we're going to use that to our advantage. So the first thing I want to do in drawing a 0 is drawing a 1. And in one line, that gets me all the way down to here. So let's just try this. Okay, so I want to make sure I call it. So I'm going to call draw 0. And let's see where we are. Okay, so draws 1, then it goes over here, then it starts draw 0, and the first thing it says to do in draw 0 is draw 1. Okay, so drawing a 1 facing down, great. So it looks like it worked. We've got ourselves, we drew a 0, okay, drew a 0, and then we drew another 1, and now we've just got to figure out how to chip away at these ones, right? Okay, now I see a problem that can make, there's something we can do to make our life a little bit easier at this point. Instead of me moving outside or making that extra move in the draw 1, I'm going to want it to stop when he's right on the last daisy. So instead of moving out of the top, I want him to stay at the last daisy. Instead of moving out the bottom, I want him to stay at the last daisy, because I have to figure out some way to get these two as well. Okay, so I'm just sort of troubleshooting this on the fly, and I'm saying to myself, oh, that's a problem that might come into play. So I'm going to try and fix that right now. So a way that I can fix that is this move that I've got here. If I take that out, what is going to happen? Sorry, I got frozen here. There we go. So if I take this move out, what does it look like for my program? Okay, I'm just going to get rid of the draw 0 for now. Okay, so let's see where I'm at if I take that out. And I step through my program. When I try to draw my 1, okay, now he stopped on, good. Now that's what I want. Instead of him going up all the way to the top of the screen, I want him to stop at the last daisy and then move over. So that's going to help me out here. Move put. Now here's a problem. If I run draw 0, if you notice the order of things in draw 1, I've got to move before I've got to put. So it's going to move first and then put. Now, if I look at this one here, because I'm already on the top row, if I move and start planting, I'm going to miss this one that he's on right now. So I do have to kind of modify my code to take care of that. You could do it manually, but I always try to build them into my functions. So what would happen if I changed my functions so that instead of putting and moving, instead of repeating it 5 times, why don't I repeat it 4 times? And then I could sort of see where I'm at, and I can manually do the rest. So in drawing 1, let's move and put 4 times, and then let's see what I need to do outside of that to make things work properly. Okay, now this is just part of testing your code and debugging and solving things as you go. Okay, so let's get up to, okay, so there's my move 4, okay, which gets me to there. So that is what is happening when we run this command for the 4th time. Now, what do I need to do after that to finish this up? I need to plant one more time. So after that, I'm going to move one more time. Sorry, I'm just thinking out loud here. No, I might not want to do that. I'm thinking I might actually cause myself more problems by doing it that way. So we might just have to work it into our main code for now. Again, I always try to build this thing so that it works. And then after I know it works, then I always go back and try to make it more efficient and more elegant. And it's very, very difficult to do your first run through the program, particularly because I didn't make a little bullet point algorithm for myself. I'm kind of just doing this on the fly. So what's likely going to happen is I'm going to get this program to work properly, but it's going to be not as efficient as it could be. It'll be okay, but I bet you anything after I'm done this program, I'll be able to go back and I'll be able to trim out and make things more efficient based on how I build my functions or rebuild my functions, or perhaps I can add a few more functions in that'll get rid of some repeated code. So I'm going to make it my goal here just to make it work using the functions that I've created and as efficiently as possible, but I know I'm going to have to go back after the fact and try to make it more efficient. So I'll stop kind of pointing out these tiny little efficiency things and just get back to making it work properly. Okay, so back to where we were. We had a very minor issue in that at the bottom here, we're going to need to move an extra step. So in the draw 0, which I need to put back in here because I deleted it at some point. So I'm going to run the draw 0 command, and then let's just see where we're at, and we'll see what sort of troubleshooting we need to do. Okay, so after running draw 0, I am right at the bottom of the screen. Okay, now that's going to cause a little bit of a problem for me because I need to take care of this daisy before I take care of this daisy. So I'm just going to take care of that one step at a time. I'm going to turn to the, I guess that would be left. Then I'm going to turn left again, plant this daisy, and then get set up for this one. So this isn't going to be the most efficient way to do it, I can tell, but it is going to work. Okay, so in my main code, after my draw 0, I need to turn left, move. Okay, then I need to turn left, move. Now you're seeing some repeats already, right? So that may be something that I want to take care of. So if I know that I need to do something twice, why don't I just put repeat 2, turn left, move. And then after that, I should be on top of the daisy, so I should put, okay. And then that's going to put the daisy, and now I'm going to move up and do the top daisy. Okay, so that's going to be 1, so I'm going to need to move 1, 2, 3 times. So instead of writing move 3 times, let's just do repeat 3, move. Sorry, this one right here needs to be indented because I only want to turn left twice. I don't want to do anything else. And this time I want to move 3 times. That's going to get me to the next daisy spot. So now I'm going to put, and then I'm going to move one more time, turn right, move, turn right. Now I'm just doing this kind of following, writing my code, following in my head where he needs to go. You may need to test this out sometimes while you're doing it, and that's fine. So looks like I've got another move, turn right, okay? So instead of move, turn right, why wouldn't I just put a repeat in there? This is part of making your code more efficient. Recognizing areas that are repeated, and then yoink, saving yourself some typing. Sorry, this one was supposed to be turn left and move twice, not just turn left. Okay, so let's test it. Let's make sure I didn't make any mistakes. And we'll run the program. Okay, excellent. I see that he is creating the 1, and then he's taking care of those daisies, and you can see the mistake right here. I didn't move. I need to move one more step before I plant my daisy. So down here, I needed to, where's my put? My put here, instead of moving 3 times, I need to move 4 times. Okay, so let's just test it and see if we fix the error. Okay, so let's just run it quickly. Okay, good. Now it looks like the error is fixed. If I zoom in here, you can see I planted this daisy, I planted this daisy. Uh-oh, what's this daisy down here? Okay, so I've got a mistake from going here see here, which means I should fix that. Somehow I missed that one before, so I know I have to fix that. And we're just testing and fixing and testing and fixing. I can guarantee you that if I had drawn out an algorithm, just a bullet point by bullet point list on a piece of paper, I would probably have to fix fewer of these. That's one of the reasons I recommend doing it so much. I'm kind of smacking myself in the hand right now for not having done it for this one. Okay, so I have to go back a little further and make sure that I take care of that. And the problem here is that I needed to go one more step up here so that I'm at the top facing down instead of standing on the daisy and facing down. And the reason that happened is because at some point I took out this line and I shouldn't have. So let's just see where we are now. There we go. Okay, so now I'm in the right spot. I fixed it up. I zoom in. Daisies are all planted in the right spot. You can tell because the number by the daisy is blue. If the number by the daisy is red, it means you've got it in the wrong spot. And I'm facing down again. So now that I'm facing down and I'm facing an entire row of daisies, now I can draw one again. So in my draw 2 or draw 0, where's my draw 0? P2, draw 0, turn left, P2. You know what I'm just thinking right now? I kind of goofed because the only thing I've got in draw 0 is draw 1, which means draw 0 is pointless because I could just call draw 1, which means I need to put different code in my 0. I tried to make myself too efficient and I kind of shot myself in the foot over it. Oh, Dunbar. Do I fix it now? Yeah, absolutely, Maria. Slap me on the wrist. I was building it into my main code, and I should have been building it into my draw 0. The problem is because I'm not always facing the same direction, this might cause problem. Anyway, I'm going to take this code and put it in my draw 0 and see if it works. But I'm not actually 100% convinced that this is going to work, just because I might be facing the wrong direction. Okay, so let's see where we are. So the only difference is I took the code from down here and I put it into my draw 0. So my draw 0 does more than just draw 1, which was kind of the point of it. All right, so let's see what happens here. Okay, I'm still in pretty good shape. Now I need to draw another 1. So I'm still inside my draw 0 function. Now I need to draw another 1. Okay, now keep in mind, this is indented, which means it's still inside my draw 0. So I'm actually accessing my draw 1 function from inside my draw 0 function. So remember, once you build a function, you can use it anywhere. So if this works properly, my draw 0 function should allow me to start at the top, facing down, and draw an entire 0. Okay, so let's just see if I draw 0 right here, if this takes me down to right there. If it does, then we're in pretty good shape. Okay, so it looks like it gets me down here, and I did plant that daisy. I can see the blue 1 there. So that draw 0 function starts here. So this is where I use draw 1, right there. Now draw 1's over. Now this is where I start draw 0, right here. Everything from this point forward is just part of the draw 0 function. So doing this, and doing this is part of the draw 0 function. Now here's something to keep in mind as you are building this program on your own. My draw 0 function is based on Reeborg being at the top of the screen, above the daisy and facing down, which means if I just move over and try to do the draw 0, it's gonna break, and I'll show you why. It's not gonna break, it's just not gonna end up in the right spot. So let's get him in position for the next daisy. I'm going to do it the wrong way and show you why it won't work from the bottom up. You're going to need to work from the top down on that one. So we need to turn left. I'm back in my main code now, by the way, back in my main code section because I've already drawn the 0. So I'm going to turn left. Looks like move twice. Move. Then I need to turn, facing downward, right? So I need to turn to the left, then I need to move, and then I turn left again. Okay, and now this should get me at the bottom of the daisy facing up. Now, so if I'm at the bottom of the daisy facing up, or the bottom of the 0, sorry, facing up, it might look like, well, I'm right at I'm right in position. I can just use the draw 0 again. Now, here's why you can't, okay? So it's because of the direction. If you're facing down, left and right are going to be opposite. So if I try to draw a 0 after I get to the bottom of this daisy right here, watch what happens. So, and this is, you know, again, why testing is so important. So I'm drawing 0, everything's good so far. I get myself into position. Oh, I hit a wall. Why did I hit a wall? Right here. Instead of moving, I just needed to, did I not turn left? Oh, ha ha ha. Look what I missed there. See, that's a syntax error, but it was very, very difficult to notice. I put in turn left, but I did not put in the brackets, so it didn't turn left. That's why I ran into the wall. Shows you how those little syntax errors can come back to haunt you. Okay, so now I'm at the bottom, and I am just at the point. Okay, I'm just at the point where I'm going to draw 0. I'm just going to back up 2 steps here. 1, 2. Okay, so I'm right here in my code. I'm at the point where I'm going to draw 0. I'm facing upward, okay, which means because I'm outside the daisy and I'm going to move and put first, at least that's what my draw 0 function says. It might look like I'm in a good position to just call run 0 and then it'll automatically go make it 0. But because I'm facing upwards instead of downwards, my directions are reversed. So watch what happens when I actually try to run this program. All right. So watch what happens when I try to run it. Did you see? Okay, maybe I'll run it a little slower. So we know that the 1 and the 0 work properly. So there's 1, there's the 0. Now, because I tried to run my draw 0 function from the bottom instead of from the top, it does this part fine, but instead of turning toward the right, it turns towards the left. Because when you're going upward, all the directions are opposite. Left is going to look different than right, depending on which direction you're facing. So now he goes down through the middle and he actually picks up. He goes down through the middle and plants daisies where there shouldn't be. If you zoom in, you'll see that they are red, because they shouldn't be there. And then he ends up somewhere way over here. So that's an important thing to realize, is that when you've got left and right directions, it matters which way you're pointing, if you're pointing up or down or north or south, depending on how you want to think of it. So instead of running the draw 0 there, I should get myself up to the right point. So I should get myself up to the same point. If I started draw 0 up here for the first one, I should start it from up there on the second one. So I'm going to get to the point, okay, where that is. Now I'm right here facing up. So I'm going to move 1, 2, 3, 4, 5. I'm going to move 6 times and then turn around. Okay, so I'm going to move 6 times and turn around. Instead of draw 0, I'm going to repeat 6. And that was move. And then I need to turn around. And I only need to turn around once. So turn around. And now I should be able to draw 0 because I'm at the, oops. Now it should work because before I try to run draw 0, I'm getting myself up to the right point. Okay, let's see if it works. Draws 1, draws 0. Okay, now this is me just in my main code. Okay, in my main code, I'm just trying to get myself back up to a spot where I can run the function again. So this is me just trying to get to the top and turn around. There we are. Okay, so I'm at the top. I've turned around. And now the next step is to draw 0. Now this one should work because I am starting in the same spot that I started the first time I drew a 0. So now when I run draw 0, it should work properly, and I get to the end. And now from that point, you just have to keep building inside. Your draw 1 and draw 0 functions are good now. We know they both work. The important thing is, are you starting in the right spot? So when I started draw 1, I started from the bottom. So I need to make sure I'm starting from the bottom facing up for my draw 1s. And then for my draw 0s, I knew I needed to be at the top left corner facing down above the daisy. So every time I start and try to run the draw 0 from this position, it will draw 0 properly. Every time I try to draw 1 from this position, it'll draw it properly. And then at the end, you just use your main code to get to the flag and you're done. Now, I will go back to that code because I know that after I'm done building this code, I will have some things in here that I can do better. I know that I will have certain things that are repeated I know that there are certain ways that I could build the draw one function that might make it a little easier for me to use. For instance, instead of moving and put, what if I put and then move? Maybe that will make it a little easier for me to use this function for the 0. So there's things that you can try after you've done it once successfully to make it more efficient, to make it more elegant. And that's always your goal as a programmer, is to make it work properly, but also to make it work as efficiently as possible. Fewest lines of code, fewest amount of memory and power and all other resources used while still getting the same result. If you could hire somebody, one person, they would do the exact same quality work, okay, the exact same quality work, but one person would take 5 days to do it and the other person would take 1 day to do it. The choice as to who you're going to hire is quite simple. If you're going to get the same end product, you'd rather have it in 1 day. You'd rather pay a person to do it in 1 day than pay a person to do it over 5 days. You always want it as quickly as you can get it, as, provided that the quality is high. And it's the same thing in programming. If it takes 1,000 lines for one coder to do it, and it takes 100 lines for another coder to do it, and the end result is exactly the same, you're always going to go with the person who could do it in 10 lines or 100 lines or whatever I said. So we want to go back after the fact and see if we can make things more efficient. Now, if you're going to do that, make sure you save 2 versions. Okay, so what I would do is I would continue on in the process I was just describing. I would get it down to the flag, make sure everything's working properly, and then I would go up to the top and I would save it. Okay, and then what I would do is I would go back and save it again, except this time I would call it something else. Instead of calling it step 7, I might call it step 7 V2, so for version 2, or step 7-2 or something like that. And then I can use that second saved file to experiment. And the reason I would save it again is because when I'm experimenting, if I accidentally screw something up, it's not going to cost me all my work, because I can always go back to the original file I saved, which I knew worked. Okay, so when you save another copy of the file and call it something different, it gives you the flexibility to play around with it. And because you might not be sure, you might think, oh, I can make this more efficient, and then you start trying to make it more efficient, you realize, I actually made it less efficient, or I broke it somehow. You don't have to worry about remembering everything that you had working correctly in the first place. You just go back to the one that worked, okay? And then if you want to try again, then you save it as version 3, V3, and then go try again. And in doing this process, you always make it so that you're not going to lose a whole bunch of work if you make a mistake. So I always recommend that if it's a larger program, you save your progress sort of day by day, and they're small programs, so it doesn't matter if you've got 4 versions of any one of your programs. It's not going to cost. It's not going to, it's not going to use a whole lot of storage space on your computer or anything like that. They're tiny little files. But in case you accidentally mess something up on day 3, at least you can go back to the beginning of day 3 and you've only lost, maybe an hour of work. Whereas if you don't save it over and over again, you might have to start right from scratch again. So I'm a fan of what's known as version control, and that's essentially just taking a copy of each day's work and saving it as a slightly different file name in order to prevent you from losing a whole bunch of work. I'm sure we've all been in the position where we've typed out multiple page reports in Word or something, and then we did something stupid, like we accidentally deleted it and saved over the old one, and then you've lost 8 hours worth of work. I'm sure that's happened to all of us. By saving it as a new version every time you put a significant chunk of work into it, you prevent that from happening. So again, when I'm naming these files, if I started out as if it was called my program, maybe I work 2 hours the first day on my program and I save it as my program. Then the next day I might go save as, open it up and then go save as my program V2, V as in Victor, V2, which usually just stands for version 2. And then I would save day 2's work on that. And if day 2 went well, that's great. Then the V2 file is the one that's working properly. And then on day 3, I would load up the day 2 version and I would save as my program V3. And then I'd work on the V3 version. And if things go well, that's great. Everything you've done by the end of day 3, everything is perfect. But let's say you make a mistake on day 4. You work the whole day on V4 and you screw it up and you accidentally delete everything, so your V4 file is broken or corrupt or something. All you've lost is that 4th day. You can go back to version 3 instead of having to go all the way back to the beginning. So that's why you use versioning. I had hoped to do if statements today, and I'm going to do that very briefly. because Maria asked me to. I'm probably going to start with this again next session to go in a bit more detail. So we're already at about an hour and a half, give or take. I'm going to take about 5 minutes here to give you a quick rundown on conditionals. Okay, so the point of conditionals, okay, we call them conditionals. I'm just going to delete all this. And you know what? I might load up a different program too. Something where we have to make a decision. Okay. Technically, I do there, but this might be a better place. Okay, this is a good one to do it on. So this is step 13, and this is a program where there are hurdles placed, and if there's a hurdle in front of Reeborg, Reeborg has to go over the hurdle. Now, every time you reload the program on this one, okay, so every time you reload the program on this one, you'll notice that the hurdles are in different spots. So you can't just build this one way, because if you build it so that it works with this particular hurdle maze, it's not going to work with this one because the hurdles are in a different spot. So now we're at that point where we can no longer just kind of do it step by step and solve the mystery or solve the maze once, because the maze changes every time. So now we've got to build our programs so that they check certain things and make decisions. Now the computer isn't making the decisions. You're telling it, you're specifically programming it to make good decisions based on conditions. So a condition can either be true or false. And this is, we're talking about if statements, and we already used these in Scratch. There's only two options. Okay, any condition can be true or false. It can never be maybe. Now, if we look at this in the real world, let's say that you have a bedtime curfew. You need to be back in the house by 10 o'clock. The condition is you need to be back by 10 o'clock. That is either going to be true or that is going to be false. So the question you're asking is, last night, were you home before 10 o'clock? There's no maybe. You either were home before 10 o'clock or you weren't home before 10 o'clock. So that's where the true and the false comes in. You don't have to specifically type in the true or the false. By putting the condition in the right spot and programming it and typing it the right way, it knows how to check and determine if it's true or false. And that'll become more obvious when I do this right here. Okay. So the condition is, were you home on time? It was either true or false. Okay. And then after you determine if it's true or false, then you have something that's going to happen based on whether it's true, or something else that's going to happen based on it's false. So maybe you get grounded. So, or maybe you have a reward or a punishment. Maybe the reward is you get to go out the next night, and the punishment is you don't get to go out the next night. So if it just in plain English here, so this isn't Reeborg commands, but it was something to the effect if, you know, home by 12, let's say. If you're home by 12, okay, the true part is what you put right under the if. So, you know, this part would be, you know, you get to go out again. And then you use an else for if it's false. So if you were home by 12, if that's true, you get to go out again. If not, that means that you weren't home on time. Maybe you're grounded. Oops. So you have two different paths that the computer can take. It can either say, hey, this is true, so I'm going to run this part, or this is false, and I'm going to run this part. It will never run both of these. Okay, you will never get to go out again, but still be grounded at the same time. That's impossible. So now all we have to do is take that same logic and apply it to something that actually makes sense for Reeborg. Okay, now if we look at this program here, what Reeborg needs to do is Reeborg needs to determine if he should move forward or if he needs to jump a hurdle. So there's a decision. Every step that Reeborg makes, he has to determine whether or not he's got to go up and over a hurdle or not. And we can't just build our program to say, hey, move up, over, down, move up, over, down. Because remember, we don't know where these hurdles are going to be. So we need Reeborg to check every single time, because every time we reload this program, these hurdles are going to be in a different spot. And we're going to use a conditional statement. So when you see this word, conditional or conditional statement, we're basically talking about if statements, if and else. Okay, so what is the logic that we need to use? Reeborg's already facing the right direction, so I don't need to check that. What I need to do is I need to check if Reeborg is facing a wall. Because if Reeborg is facing a wall, that's essentially what the hurdle is. It's just a wall in the middle of the maze. If Reeborg is facing a wall, if there's a wall in front of him, then we know we need to somehow hurdle. If there's no wall in front of him, then we could just keep moving. So that we build our if statement based on that. So if, okay, if what? If there's a wall in front of him. And now, how do you detect if there's a wall in front of him? This is built into Reeborg. Okay, this is one of those things that you can just do. So if I go back and I look at my Reeborg keyboard, and look at that. There's a whole box dedicated to conditions. So these are most of the conditions that you're going to need to use in order to detect things. So what's the condition we're looking for? We could either use front is clear, or we could use wall in front. I think wall in front is going to be easier to use. Okay, so that's our condition. Go back to our code. If wall in front. Okay, built right into the program. So if wall in front is asking, is there a wall in front? And there's only two possible options, true or false. Okay, there's nothing in between. So if there's a wall in front, if that's true, I want him to jump over the hurdle. And what does jumping over a hurdle jumping over a hurdle indicate? It looks like we're going to have to turn left, move up, turn right, move, and then get facing the same way. So if a wall is in front, we need to do a bunch of stuff to get over a hurdle. Now, because there's more than one hurdle, I should definitely make a function for hurdle, because I'm going to have to do it more than once. So what is involved in getting over a hurdle? Okay, it looks like we're already going to be facing the hurdle and right in front of it. So we need to turn left, and we need to move once to get up, and then we need to turn right, and then we need to move again to get past the hurdle, and then we need to turn right again, and then we need to move to go down, and then we need to turn left. Okay, so I just kind of did that in my head, but I'm thinking if I'm facing the hurdle right here, I turn left, I move, I turn right, I move, I turn right again, I move, and then I turn left, and then I'm facing the next hurdle. So that looks like that's going to work. Okay. The question is, do I need to run it or not? So we already determined, as part of our if statement, the condition is there a wall in front? So if there is a wall in front, you always put the true part first. If there is a wall in front, I want to hurdle. And remember, I built all this into hurdle, so I just need to run hurdle. I don't need to copy and paste this information every time I want to jump over something. So that's the true condition. And now you can have more than one thing in your true condition, but this is all I need right now. All I need to do is hurdle. So what if this is false? If this is false, that's what the else is for. So if there is no wall in front, or if wall in front is false, and again, you don't have to put equals true or equals false. All you have to put is if wall in front, and the computer will determine, is this true or is this false? So if the wall is in front is true, it's going to hurdle. If it's not true, what do we want it to do? Well, if there's no hurdle in front of him, he can just move. Okay. So let's see if this works. Okay. Now, we can just look at what's in front of us and say, well, there's no hurdle in front of him right now, which means it should run the else, and it should just move him forward. Okay. Now, we've only done this whole chunk once. We haven't repeated it yet. So it's only going to work for the first space. But let's see if it works, because we might have to go back and fix something if it doesn't. So, okay. Let's get if wall in front. We expect this to be false. So we are hoping that from this line of code, it skips over the hurdle and goes to the else and runs the move. So it says, is there a wall in front of you? And it says, no, there isn't. So I'm going to go to the else, and I'm going to move, because that's what I'm supposed to do if there's no wall in front of me. That's it. That's all our program does. That's all we asked our program to do, is look at the first hurdle. Okay. Now I have to reload my program, so the hurdles might be in a different spot. And this is the whole reason we're doing this. Okay. Now we need to know how many times we need to repeat this process, because if we just do it once, we're only moving between 1 and 2. We're never getting any further than that. So how many times do we need to check and either move or hurdle? It's the number of times that it takes us to get to the flag, right? So that's going to be what, 12 times? So if I put all of this stuff, repeat, is it 12 or 13? I think 12, but we'll see. I'm going to put all this stuff inside a repeat 12. So remember, I've got to make sure that my indents are proper. This whole thing is inside the repeat 12. the hurdle is under the if, and the move is under the else. So what this is going to do is it's going to check for each of these steps, 1, 2, 3, 4, 5, etc. Every time it's going to check, is there a hurdle in front of me? If there is a hurdle in front of me, I'm going to go over it. If there's no hurdle in front of me, I'm just going to move forward. So it's just going to keep repeating that 12 times, and by the 12th time it's done, it should be at the 13th, which means you should be past all the hurdles and into the green flag section. So let's just see. Okay, so let's run it. Okay, step by step, repeat 12 times. Anything underneath this and indented repeats 12 times. So is there a wall in front right away? No, there isn't, which means it should do the else move. Great, now it's going to repeat again because I told it to do it 12 times. Is there a wall in front? No, move. Is there a wall in front? No, move. Is there a wall in front? Now, there looks like there's a hurdle in front of us. So if our program's working properly, if wall in front should be true this time, which means it's going to run the true part, which is hurdle, which means it doesn't run the else. It only runs the hurdle or it runs move. It doesn't run both of them. So hopefully this time it says if wall in front, yes, we're going to hurdle it, which takes us to the hurdle code, and the hurdle code gets us over the hurdle. Now it's still going to repeat because we're not at 12 yet. Is there a wall in front? No, move. Is there a wall in front? No, move. Is there a wall in front? Yes, hurdle it. Is there a wall in front? Yes, hurdle it. Is there a wall in front? No, move, move, move. Yes, hurdle. And voila, we're done. That's how an if statement works. It's actually not that much, it's not that complicated. As long as you understand that you have to basically ask a question with your logic. Is there a wall in front of me? It's either going to be yes or no. If it's yes, then you're going to do the first chunk. If it's no, you're going to do the second chunk. The other thing you need to know about an if-else is that you can run an if statement without an else. Okay? So you do not necessarily need to have the else. In this situation, it worked well for me to have an else because I did want him to move if there was no hurdle. But if there was another situation where you just need to check something, you might just have the if statement with no else. You don't always need to have an else. Okay? Most of the time, you're going to have an if and you're going to have an else. Basically, it's a do one thing or do the other. If you need to have more than one choice, there's something called an elif, which is part of the same structure, but instead of having you start with an if, you always start with an if, but you might also have an elif, which means it's going to check something different. So if wall in front is false, instead of skipping right to the else, it's going to check the next thing. So maybe the next thing you're going to check is elif wall on right, I believe, is also something you can check. If there's a wall on the right, I don't know, maybe a put or something like that. It doesn't matter. The point is, you can have as many of these elifs as you want. So elif facing north, maybe. I think that's another thing you can check. And then maybe you take, if that's the case. I mean, I'm just making things up right now. The point is, you always have to start with an if, and you need to check something. So if this is false, it just goes to the next thing. So if there's no wall in front, it'll go and check the elif. If there's no wall on right, it'll go down to the next elif. If he's not facing north, he'll go down to the else. So it checks things in order from top to the bottom. And at any point that it turns true, it stops and does that thing. So in this particular structure right here, and this is all part of one structure, the if, two elifs, and an else, it's only going to do one of these. It's either going to hurdle, it's going to put, it's going to take, or it's going to move. It's not going to do any more than one of those. So for instance, let's just say that the only one of these that's true is the facing north one, okay? So what's happening is if wall in front, that's false. So it goes to the next one and it checks. Okay, is there a wall on the right? Nope, that's false. So it goes to the next one to check. Is he facing north? He's facing north, that one's true, then it's going to take, and then it doesn't do anything else. So it's only ever going to do one of these, never more than one. And if you do have elifs, you can have as many as you want, but you always have to have an if to start, okay? And usually you're going to have an else at the end. You can never have if, else, and then elif after. It always has to be in this order. Ifs first, elifs second, else's third. You do not necessarily have to have elifs. You do not necessarily have to have an else. Obviously, you always need an if. But if you do have those other ones, they have to be in this order. Do you need to have anything in brackets? If object here, dandelion. That's an excellent question. I saw some people doing that already. You do not. It doesn't matter what object you're standing on, whether it's a strawberry or a dandelion or a newspaper or star or whatever, it will detect that properly. So if you say if object here, if that's the question you're asking, it doesn't matter what you're standing on. As long as you're standing on something, that will be true. Okay? So these are the two things that I saw that I've seen people doing that are not necessarily wrong, but they're just more code than they need. For instance, if object here, and then in brackets dandelion, and do something down here, this will work, but only for dandelions. Okay, so it's not necessarily going to break it. You don't need this. If you just put object here, okay, there's probably only going to be one type of object in any one of these, so it doesn't really matter if you're looking for a star or a dandelion or an apple or a newspaper or something like that. You can just use if object here with the brackets and nothing in the brackets, and it'll work fine. There's at no point in any of these steps do you actually need to say, hey, pick up the dandelions, not the apples. So you don't need to worry about that. Here's the other thing. If object here equals true, this won't break it, but you don't need the equals true part. That's what it's checking. Okay? It's checking, is the object here? If the answer to that is yes, this whole thing just automatically gets turned to true in the computer's sort of processing, and it'll run this. So you do not have to run a if object here do something, or maybe the next thing is else object here equals false. By the way, two equal signs is how you do equals in Python. You do not need to do this in order to set up your if statements. It assumes these things. Okay, so you do not need the equals true on the if statement. It assumes you're checking if it's true or not. And you don't need anything on the else except for the colon, because it can only be one of two things. If it's not true, it has to be false. Okay? So you don't need to say it's only false in this condition. No, there were only two options in the beginning. If you told me it's true, that's great, it's true. If you told me that it's false, well, then you have to run the else. You can never, have more than those two binary options, one or the other, yes or no, 0 or 1, true or false, right or wrong. That's the Boolean algebra that we looked at in computer history. So that should give you a pretty good idea of how to use the if statements too. I might refresh those a little bit on the next live session, because that's what I was going to do in that one anyway. But now that you hopefully understand how to do loops and how to build functions, import them from the library, and use conditional statements, you've basically got all the tools you need to get all the way to the end. The only thing that's going to be happening is you are going to use a couple more types of loops, which I will also discuss, and the mazes become more difficult, and the logic, the problem solving that you need to do to get from the beginning of the maze to the end of the maze, doing all the things you need to do in the middle, those are going to be much tougher logic problems to solve, which is going to mean it's much more important that you start jotting down algorithms on a separate piece of paper, so that you're very logically and sequentially checking the things that you need to check and making the decisions or the conditionals that you need to check in order to handle what the program throws at you. And from about 13 on, you're going to see a lot of steps where the room size or the things you need to pick up or the hurdles you need to jump over are in different spots every time you reload the program. So just because you solved it once doesn't mean that you've solved it every time. In computer science, it's something we call the generalization of a solution. You can have one specific solution. For instance, if I was just given this right here and I knew it never changed, I don't need decisions. I can just move, 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 jump, move, 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 jump, move, 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 jump. The problem is, if I code it that way, even though my specific solution worked for that one problem, every time I change the maze, or every time I change where the hurdles are, it doesn't work. So you always want to be able to build a general solution that works in all different situations, as opposed to one narrow little solution that will only work for one problem. So your challenge is going to be, for most of these, making your program work, even though we know the room size is going to change and the objects are going to be in different spots. Your goal is not to be able to fix it once and get one check mark. Your goal is to be able to, I need to be able to reload this program 5 times, and it needs to work perfectly all 5 times, even though the room changed or the objects changed. So that's where the difficulty lies, and that's where it becomes very important that you start jotting down the order in which things need to happen. So what needs to happen in the order in which they need to happen. And remember, it's just a plan. at any point, if your algorithm was wrong or you forgot to include something, you always go back to it and cross things out and add things in and whatnot. But if you have a plan to start with, it'll be much more efficient. And remember, we slapped my hand for not doing the algorithm for the 0 and 1 assignment ahead of time. I probably would have built it, we got to the end, but I probably would have been able to build it much more efficiently if I'd actually had a jot note section to go down. The only other thing I just want to show you while we're talking about if statements is just have a look at the conditions. You can't check everything. Sometimes you're going to need to check the opposite. So you can check, are you at the goal? And by the way, the goal is the house or the checkered flag or I think blue colored spaces or something like that. The goal handles all of those. So it's checking, are you at the house? Are you at the check flag? Are you at the blue space? Front is clear, is pretty obvious. Is there a wall in front of you? Or is there water in front of you? Right is clear. Okay, so is there something on the right of you? When I'm walking forward, is there a wall on the right? Is there water on the right? Is there something on the right? Wall in front we just used for the hurdle. Wall on right is specifically a wall, which is the red thing. It doesn't handle water or anything like that. It just handles red. Object here is any object, whether it's a strawberry or a dandelion or a star. Carries object means, do you have anything in your bag? Remember, for the 0s and 1s, we had 500 dandelions in our bag. So as long as there's something in your bag, carries object will be true. And is facing north, you hardly ever use. It just means is he facing the top of the screen. So those are the things you can test. And if you need to test something that's not on this list, you might have to be a little creative about it. So at that point, you might be checking something like if not wall in front. But sometimes you can check something by using not. So instead of checking if wall in front, I can check is there not a wall in front. So I'm actually checking the opposite, right? Because if wall in front, let's say I'm right where I am right now, here. If I check if wall in front, that's false because there is no wall in front of him. It's an open space. If I check not wall in front, that would be true because it's true. There's no wall in front. So one of the things that you're going to run into pretty quickly is you're going to have to be able to use the not keyword in front of your logic. Okay, not for everything, but there's certain things you need to test for that aren't built right in, so you're going to have to be a bit more creative. To answer your question, Griffin, yeah, we're done. That's all I wanted to do today. That's a pretty fair, fairly detailed description of everything you need to know to get through the Reeborg all the way to step 20. The rest of it is critical thinking skills and your ability to solve problems. And if you need help, if you are struggling with one, I will always try to help you. But be noted, I'm going to ask you. I'm going to ask to see your algorithm. So just the little bullet points you made, or I may ask you just to send me a copy of your code, copy and paste into an email, so that I know that you're trying and you're trying to independently solve these problems. I'm always happy to help, but I'm not willing to kind of just do things for you. I want to make sure that I'm leading you in the right direction and helping you move forward. So, are there any other questions? Sorry I kept you so long today, but it was probably a reasonably important session. The next one will be shorter because we've done most of this before. Yeah, anytime. Again, I'm always available by email. If you're struggling with something, send me an email. If you're asking about a specific program or a specific step in Reeborg, you might as well just copy and paste your code, like literally just go to Reeborg, copy, Control-C, Control-V into an email, because I'm going to ask anyway. If you're asking for help for a Reeborg problem, I'm just going to say, hey, email me your code right now so I can have a look at it and point you in the right direction. So you might as well just do it on the first email. But let me know how I can help. You have a great day too. Remember, I'm not here on Friday, so if you got any questions, get them to me tonight or tomorrow. And have a wonderful weekend if I don't see you before then, and I'll see you on Tuesday. Take care.